This is 1.5, all right? Part of 1.5 we've already done, and that was composite functions, all right? So this is going to be arithmetic combinations of functions.
Arithmetic?
That's exactly right. How you pronounce that word depends on if it's a noun or a verb. That's why I didn't call it arithmetic. Arithmetic combinations. Does that sound like it makes sense? No, it's arithmetic. Arithmetic combinations of functions. I'm doing my, I don't know, do some arithmetic. That's a verb. That's doing something. What is the arithmetic that you can do, guys?
Math.
What? So they'll be adding. What else can you do? Subtracting and multiplying and dividing. Those are the things we're doing to functions. This is easy. We got this, okay? So you can add, subtract, multiply, and divide. So let's talk about them, okay? Dallin? Oh. F of X? Like, it's not even quiet. You can't be sneaky with it, okay? So, f of x is equal to 2x plus 1. G of x is equal to x squared plus 2x minus 1. Alright, so let's add first. All they want you to do is find f of x plus g of x. Now, I will tell you this. There is a different way that I can write it. It's still the same thing, but it looks a little different. Don't let it mess you up. I could write, hey, what's f plus g of x? I mean, what do you think that means, people? You're adding the f function and the g function. So there they are. So 2x plus 1, that's the f function, plus, now when I use a plus sign, do I need parentheses or anything? No, you don't. You don't put them in there. Y'all don't put parentheses if you don't need them, because they just make your problem look more complicated. Okay? So now it looks like this. Well, I'm going to start with my highest exponent. What's your highest exponent? Okay, are there any more x squared? So I just cross him out and write him down. Okay? Now, here's a 2x. Are there any more x's? So what's 2x and 2x? Okay, so plus 4x. And then a plus 1 and a minus 1. That's 0. They cancel each other out. So there's my answer. Now, was that hard? Okay, so somebody's going to look at this and they're going to go, ooh, that was way too easy. I better do some stuff to it. People, that's the answer. Don't be doing stuff to it. Okay, don't factor it. Don't solve it. You can't solve it. You don't know what it's equal to. You understand? That's the answer. Write in the blank and go on about your business. Okay? Brent, question? Yeah, no, you don't know. That's it, people. It didn't say find f plus g of x and then factor it if you possible. It didn't say anything like that. It just said find it. Oh, I found it. Okay? Now, what if I asked you to do this? You're just going to plug it in. People, is that... I would, but you don't have to. Okay? I think it's easier to do this. Plus, it makes you practice skills. Okay? So now, you're just going to plug it in. Negative 2 to the second power. Do I need parentheses around that negative 2?
Yes.
Anytime you raise a negative number to a power, you need to put parentheses around it. Okay? Especially if you're depending on a calculator. Plus 4 times negative 2. What's negative 2 squared, guys?
4.
What's 4 times negative 2? What's 4 minus 8? So f plus g of negative 2 is negative 4.
Let's do f minus g.
Okay, let's do f minus g of x. That sounds like a good idea. So f minus g of x. So f of x was 2x plus 1 minus. Now, is there anything important here?
Change the sign.
Okay, so we're going to put parentheses around it because I want to subtract the whole thing. All right? So, what was it? Come on. X squared plus 2x minus 1. Is that right? Okay. What is a minus sign outside parentheses? Change the signs. Okay, so I'm distributing that negative 1. He's going to change everybody's sign. What's the opposite of a positive x squared? What's the opposite of a positive 2x? What's the opposite of a negative 1? And now I'm going to do the same thing that I did earlier. I'm going to start with my highest exponent because that's putting it in proper standard form. Okay? So that is a negative x squared. Alright? And then I have 2x and minus 2x. What's that make? Nothing. And then 1 and 1 make. Now, do you think I know what number to put in here to make you mess up? Yeah. At least 2 kids. Last class it was more than 2. Come on, darling. Okay, okay.
Did you even prep on how can't you make me take practice SAT prep? And on one of them I've only made like sort of like 4 questions out of that.
Good. That's very good.
There's a lot of like functions.
Are there a lot of logarithms? Nope.
What's logarithms?
Oh, I guess you're not in there.
You have to take the SAT. The real SAT. And you have to score
You have to make a certain score to be what they call college ready. You have to make a certain score on the SAT test. If you don't make that score, then you have to take the PSI test and score a certain score on that. If you don't score on the PSI, you can retake it as many times as you want to. The school's going to provide it for you free the first time. After that, I don't know if the school will provide it or if you have to go to Lamar and take it.
On the SAT. Only on that. I think 3 kids are in college. 2. I think it's 2.
Yeah, you don't have to. You don't have to take college calculus to take calculus. You can't just enroll in. It's the same class. It's just that if you want the college credit for it, you have to pay for it. Other than that, it's all the same. Okay? So even if you didn't score the score and you didn't want to do all that stuff, you could just say, I'm just taking it as high school and I'm not paying for it. You could take the AP test and CLEP out, is what they call it. AP calculus test, pretty tough, but Mr. Ryan's kids have done pretty good. AP stats test, probably one of the hardest AP tests there are, but Mr. Collyer's kids have done pretty well too. So.
I like that.
Alright, so, not taking care of the students. Alright, so here it goes. Negative 2, sorry, and then squared plus 2. Alright, does this negative cancel this negative out? That's where the mistake's going to be, because you're looking at that, okay, and unless you're really good and know what you're talking about, you're going to go, oh, that's a positive 2. 2 squared is 4, 4 plus 2 is 6, it's 6. It is not 6, people. The order of operations says you have to raise to this power first. Any number raised to an even power is what? Positive. And the opposite of a positive, what, did I say it wrong?
No, I said
that is an even power.
I said it wrong.
Okay. Like any number, I don't care what kind of number it is, if it's raised to an even power, it's going to be a positive number. And if you take the opposite of a positive number, you will always get a negative. So this right here will always be negative, guys. Okay? That's what my brain says. Alright. So, negative 2 squared is 4. What's the opposite of 4? What's negative 4 plus 2? So there's my answer, negative 2. Alright, anybody got a question? Okay, so let's multiply. All right? Let's multiply.
Oh,
Now, you know which one's going to be the hardest. Yeah, and it's not the hardest, but when you have to do other things to it, then they make it the hardest.
didn't we learn that last year in multiplication?
Uh-huh. Yeah. So f of x is equal to x squared. This is not hard. G of x is equal to x minus 3.
Wait, why'd you change that?
I don't know, because I did in the book. I changed it. I like to use the examples in the book. All right. So here's what they're going to write. Now, this is going to look kind of crazy. Yeah. Look. What is that, guys?
That's the years. That's good. That's good.
Yeah, it's a multiplication problem. When it has two things beside each other and no sign in between, what does it mean? Multiplication. What if I put a dot in between them? How would I know it was multiplication and not composition? Yeah, it's not solid. It's just a little circle. Okay? It's not a dot. It's a circle. So here's a dot, and here's the composition. All right? Do what now?
The X isn't not there like that either.
It's no, it's not. All right. So this means we're going to multiply f of x, x squared, times g of x, x minus 3. It's the distributive property. What's x squared times x? What's x squared times negative 3? Boom. That's easy, isn't it? Okay? All right. Save the best for last. This time I'm going to tell you that f of x is equal to the square root of x, and g of x, we're going to talk about this one for a little bit. G of x is equal to the square root of 4 minus x squared. Okay? 4 minus x squared. Yeah, all over the place. So let's see. The first time, let's just do this. Let's find f over g of x. Okay. Now, is this going to be hard?
Yes.
No, people. You put this on top, and you put this on bottom.
Put a square root of it.
All right, or you can separate it. Okay? So, this is the answer. This is it, people. You can't do anything to it. Can I take the square root of 4 and the square root of x squared? That's right. If it's added or subtracted, you can't do it. All right? If you want to know if you can, y'all, sometimes you know how when you look at a problem like that and you go, whoa, I wonder if I can do that. If you want to know if you can do it to some numbers and see if it's true. Like, make up some nice pretty numbers. Don't just do anything. All right? 25 minus 16. What is the square root of 25? Minus, what's the square root of 16? What's 5 minus 4? 1. Well, let's see what it really is. What is 25 minus 16? What's the square root of 9? Are these equal to each other? They're not. You can't do that. If you want to know if you can do something, put some numbers in there and say, hey, does that really work? Can I do, is that legal? So, and they'll tell you if it's legal or not. All right. So, this is as good as, hey, what about those x's? They're both underneath the radical. Can I reduce them? Why? Yeah, that 4, you can't, if you can't take it out of everybody, you can't take it out of anybody. So, like I said, this is the 4th time. This is the answer, people. This is all you can do. Okay? Now, so how can I make that hard? What if I said, what's the domain of this function? Okay? What's the domain of this function? Do we have a lot of things to consider? Yes, you do. Okay, so let's consider this function. Look, he's got restrictions up here and down here, right? He's got restrictions all over the place. He's got x's under the radicals, and he's got x's in the denominator. Think about that, okay? So, what's the restriction right here? That's it. X is greater than or equal to 0. What's the restriction right here? Oh, there's 2 of them. What's it going to be?
X is less than or equal to plus or minus 4. It's
Mm,
in between plus or minus 4.
yeah, it's in, no.
Right?
Okay. Joe saw something that's really important. Most kids don't, yes. most kids don't see this. I know some of y'all are doing stuff in your head, but remember this. We're recording this lesson for everybody, okay? So a lot of kids can't do this in their head, so they need some more guidance on it, all right? So do you agree that when there's something under the radical, you take what's under the radical and you say you must be greater than or equal to 0? Does everybody agree with that? Now, Joe, what's the problem with that? Yeah, y'all, this cannot be equal to 0. You can't have 0 in the denominator. So all I need to do is really pull that little equal to sign off. Do you agree with that? Okay, so what's under the radical can be great. It has to be greater than 0, but it can't be equal to 0 because it happens to be my denominator. All right, so this is the one where you just kind of graph it, and all I need to know are those two little x-intercepts. Everybody agree with that? Guys, listen to me. When you want to find those x-intercepts, don't use that inequality sign. This is it. But this is what I'm going to try to solve to find them. Okay? Now, I'm going to add x squared to both sides. And then what am I going to do? So x is equal to what? Plus or minus 2. Remember, when you're solving an equation and you take a square root, you have to consider the plus or minus. So obviously this is negative 2 and this is positive 2. Okay, so here's where the problem's going to come in for those kids that never really quite understood how to do this, but they know that it always goes from negative infinity to that number and then this number to positive infinity. Is that true in this case? Why? That's exactly right. Guys, when you don't understand why things are like they are, then you're not going to get it when someone changes it up. So the only thing different about this is this parabola opens down. So he looks like this, somewhat. Sorry. Okay, so what part of that parabola is greater than 0? The hump or the tail? Yeah, this time it's the hump. That only happens when it's opening down. Okay, so does everybody agree that it's all these numbers in between negative 2 and positive 2? Inclusive or exclusive? Very good. Y'all, it doesn't include these. Normally it does, but here it doesn't because they're in that denominator, and we have to exclude that 0 out. Okay, so that's from negative 2 to positive 2. But we also have this restriction too. You have to incorporate both of those restrictions. It's called an intersection. I want the intersection of this set and this set. I want what they both have in common. And only what they have in common can be my domain. Okay? So if you can't look at it and tell exactly what it is, then you can always draw it on a graph. And especially if you use different colors, you can see it. Like, I'll do this yellow one right here. He goes from 0, included, to infinity. Alright? This one, I'll do it in green. He goes from negative 2 to positive 2, but they're not included. Okay? Now, my domain is the intersection of these two graphs, what they have in common. So it has to be where the green and yellow are. So I start here and I'm just green. I hit the yellow, so I'm yellow and green. So it starts at 0. Does it include 0? And it goes all the way up until what? Does it include the 2? And that's my domain. Okay? Now I'm going to ask you to do this one. I want you to find that function, okay, and then I want you to tell me his domain. Those up there. He just flipped it, is all I did. It's really not going to change it a lot, but it is going to have something happen. So you're going to have to, it's going to show me if you know what you're talking about or not. Okay, y'all got it? Okay, so let's talk about it. Now, y'all, am I going to take any of this stuff into consideration up here? Y'all, it's all work for you up here. Okay, why would you not take that into consideration? Okay, so this domain right here, what's his domain? What's it going to be? Yeah, this time it's inclusive because it's not on the bottom. So it goes from -2 to +2, but it includes it. Okay, on the because it's on the bottom here. It's where it wasn't included. Here it's not on the bottom. But here x was not on the bottom up here, but it is on the bottom down here. So what's the x going to be? Yeah, greater than 0. Not greater than or equal to 0, but greater than 0. Okay, can't be equal to 0 because that creates a 0 down here. So now he's going to look like this. Still got the same thing. -2 is those important parts, 0 and 2. The blue looks like this, from -2 to 2 inclusive. The yellow looks like this, from 0 not inclusive to infinity. So my domain starts where? 0. Inclusive or exclusive? All the way to inclusive. Okay, so is there any way that I could check this on my calculator? No. Is there any way I could check this on my calculator? Yeah. No, you could just put this in your calculator, all right? And now look, I wouldn't like try to work it on my calculator, but it is a good thing to check it on your calculator, all right? So if you could go to y equals, let's see, this is the second one that we did, right? The one we just did. The square root of 4 minus x squared divided by the square root of x. If I graph it, there it is right there. What can I not tell from the graph? Yeah, who's included and who's not included. I can see pretty well. I think it goes from 0 to 2 like we talked about. Okay, but how could I tell if something was included or excluded? Yeah, you could go to your table. If it wasn't a pretty point, you could always go second and calculate a value and put your value in there. Okay, but you can go to your table. You can see in this table that, see, it stops at 2. Everything above 2 is an error. And then, oh, stop. So here you can see that the 2 is included and the 0 is not included. And that's the way we did it. Okay? Everybody okay? All right. So you have 10 minutes left. If I were you, I'd probably take me out a sheet of paper and I'd try to write down the 13 functions and then see what I knew about them. Okay? And then see what I needed to study tonight. That test is tomorrow. And then when you finish the test tomorrow, you can work on your worksheet. It'll be due on Wednesday, and your test on Wednesday, Thursday.